All right, so this is our first lesson on measuring on angles and parallel lines. This one is on measuring and constructing angles. Lots of this will be review, um, but there's a lot of kind of terms in here, more terms than what we use in some of the previous units. So um, they are pretty straightforward, but you will have to know what these terms are for this unit. So starting off, we're just going to talk about what are the different types of angles. So it asks us to label or identify each of these angles as either acute, right, obtuse, straight, or reflex angles. So let's start by just talking about which one each of these is. Okay, an acute angle, the very simple way to remember this is that it's small, like an acute angle. Okay, acute being small. So an acute angle is small, which means it's an angle that is less than 90 degrees. Okay, so I'm going to say it's less than 90 degrees. The other way I could say this maybe would be saying like between 0 and 90. Those are acute angles. Okay, so on here, an example of an acute angle would be this one. This one here is an acute angle. A right angle is a 90-degree angle. Okay, so that's a corner. And so a right angle is this one here. This is a right angle. That's the one that you use the most in previous math classes. So that one's that you're probably pretty familiar with. An obtuse angle is kind of the next biggest. So it is bigger than a right angle. So it's bigger than 90 degrees, but smaller than 180. So I'm going to say is between 90 and 180 degrees. So that's between 90 and 180. So this one would be right here. Okay, 90 degrees it's always going to make that like L shape right here. That would be 90. And so we can say this one's bigger than 90. This is going right to 90 and then past it. So that one is going to be our obtuse. And then this one's nice and easy. Okay, a straight angle is 180 degrees. Okay, that is a straight line. It's going from here to here would be 90, and then going another like L turn. Okay, another 90 degrees gets you to a straight line. That is our 180 degree straight angle. So anytime you have any straight line, okay, that is 180 degrees. You can basically just like pick a point on it, and to go from there to there would be a 180 degree turn. And then lastly, we have our biggest one, which is reflex, which is bigger than 180 degrees. So I'm going to say 180 plus. So that would be this one. That's like more than a half turn. Okay, to here would be 90. To here would be 180. 3/4 turn would be 270, and then even further to here, this looks like it's like 300 and something to get all the way to there. Okay, so anything bigger than a straight angle, so that's more than 180 degrees, that's going to be our reflex angle. All right, so that's our angle review. And then this is like, okay, without having it drawn in front of you, do you know what each of these was? Okay, we said that this one, acute was less than 90, right was 90, obtuse was, okay, so this was 90, obtuse was 90 to 180, straight is exactly 180, reflex is 180 plus, and acute was less than 90, so we'll say 0 to 90. So then here we'd say, okay, less than 90, so this one's acute. This one is bigger than 180 degrees, so it's going to be a reflex angle. This one is bigger than 90 degrees, but smaller than 180. So this one would basically be like, if this is 90-degree angle, that would just be slightly bigger than that. Okay, so this one is an obtuse angle. Smaller than 90, so acute. 180 exactly is a straight angle. Between 90 and 180 is obtuse. Bigger than 180 would be a reflex. And bigger than 180 is a reflex. That's going to bother me. There's an E for obtuse. So this example that says to estimate the measure of the following angles and then measure with a protractor to check. Okay, so estimating is really important. If you can estimate the angle, it will help you make much or way fewer mistakes in this unit. So if I were to look at this, I estimate by my quarter turns, right? So I know that like this would be 90 degrees. Often we draw a little box there to show 90 degrees, but I know that that's a 90-degree angle. I also know that this would be a 180-degree angle. I know that to go like This is 90, 180, that's 270, that's another 90 degrees. And to go all the way around, if it went all the way around in a full circle, that is 360 degrees. Okay. So this is how I use stuff to estimate. So this one here is bigger than 90 degrees. Okay, it's bigger than just this normal L shape here. And so, but if this would be 90, and this would be 180, it's a lot closer to 90 than 180. So I'm going to estimate that this is maybe, let's say, 110. Okay, and then I would measure with a protractor. Before I do that, I'm going to estimate this one. Okay, 90 degrees would make like an L shape like this. That would be 90 degrees. Halfway between 0 and 90 would be 45, and this looks like it's close to halfway, but maybe not quite, so I'm going to estimate that this one's 40 degrees. Now, let's talk about using a protractor. Okay, so for the sake of doing this on the computer, I've got a website here that just gives an example of how you can use a protractor. So this here is a protractor, and protractors have this little kind of crosshairs here. Some of them might not have like this little bottom line here, but they're going to have like a straight line going across, and it's going to make about a T here, a little crosshair. So if I want to measure an angle, let's say I'm going to measure angle B. I need to take this crosshair and line it up right on the corner, right on the vertex there, like that. A common mistake people make is that they will line it up with the edge of their protractor right here instead of with the crosshairs here. So we need to make sure that it's not just like this, it's lined up right on the corner of the vertex. All right, now the next thing we need to do is not just go straight to looking at the numbers. Okay, before we do that, we need to line up one of our bottom lines here, one of our zero lines, with one of the sides of the angle we're trying to measure. So what I mean by that is I'm going to rotate this until it gets, oops, my apologies. Okay, like that. And that's about as close as I can get. So let's say right there. So I'm going to line this bottom line up so that it lines up perfectly with here. And then now I'm going to look at what's the measure. But people will often get these two numbers confused here. Here it looks like it's very close to 50 or 130. And people will often just go with the top number because they think that's going to be the right one. But what we need to do is think about, like, what are we measuring? We're starting just right at this line would be a 0 degree angle. If we just had a straight line like this, it hasn't rotated at all, it'd be 0. And then as we rotate more and more, we're going to be getting bigger and bigger. So 0, 10, 20, 30, 40, 50. So here we've gone about 50 degrees of rotation to get to here. If we had said our answer was 130, well, first of all, if we were estimating, we would know that it should be smaller than 90. But what we had done there is if we had said 130, you're starting at 180 and counting backwards. You say like 180, 170, 160, and that's not how we're measuring. We're starting at 0 and counting up. So be careful with the numbers here. If I was measuring this angle here, for me to start at 0 now, I'm using the outside numbers. Okay, 0 is on these outside numbers. I'm counting up 10, 20, 30, 40, 50. For this one, had I said 130 here, I'd be starting at 180 and counting down. Okay, so you need to be careful if you're using the top or bottom. It just depends on which kind of side of your protractor you're using. Just always make sure you're starting at 0. Okay, and in this case, let's see if I can zoom in. If your lines are ever too short, you can always use a ruler and draw them to be longer so they line up right with your protractor here, and that makes it easier to tell, exactly how big this is. So my line isn't perfectly lined up here, so it's probably off by a degree, but this would be, between 40 and 50. And if this is 40, that's 45, 46, 47. It looks like 47 or 48. I'm going to say 47 degrees would be this one. And so that's how we use a protractor to measure.